Health and safety rules need to be adhered to, which includes the wearing of appropriate safety clothes and safety boots before any work commences on the Kavango block brick construction site. Site clearing involves the removal of dead roots, rubbish and rubble. All loose materials need to be removed. The area on which construction is to take place must be leveled. Setting out of the foundation needs to be done in accordance with the dimensions as set out in the approved plan and drawings. Pegs need to be inserted to indicate the actual position of the foundation. Compaction of excavations using a rammer compaction machine to ensure optimum compaction should be used. Additional compaction takes place using a plate compactor. Completion of excavations and setting up of formwork for raft foundations for 140 masonry walls. Formwork for the concrete is carefully set out, ensuring that the positioning is correct. Shuttering braces need to be positioned in order to ensure correct position of the formwork. Positioning of electrical services must be carried out by a qualified electrician in conjunction with a KBB inspector. DPC membrane or damp-proof coarse plastic sheeting is positioned throughout before fixing of steel and casting of concrete. Steel is positioned according to the engineer's specification in conjunction with the KBB site inspector and qualified electrician. The steel mesh is secured and fixed as per the engineer's specifications. Prior to casting of concrete, all steel fixtures are inspected and final preparations conducted, including the final placing and positioning of the electrical services conduits by the appointed electrician. The workable concrete, as per the engineer's design, is cast. The concrete must be vibrated using a high-frequency internal vibrator with a minimum frequency of 600 vibrations per minute. Concrete needs to be leveled whilst wet using a long and straight level. Once level, the surface bed needs to be properly wood floated in order to provide a quality finish. Formwork and bracing is removed in preparation for first course of the 140 thick wall structures. Step 1 of the KBB superstructure construction phase. KBB starter blocks are laid out dry, starting from the corner first. Once the blocks have been laid out and dry, they are bonded together using conventional mortar. DPC underwalls must first be positioned prior to bonding the first course starter block with conventional mortar. It is imperative that the first course is laid straight and level and must be thoroughly checked as per conventional building standards using an accurate water level. Step 2 of the 140 thick superstructure construction. Door profiles are placed strategically for exact measurements for the doors. Corner profiles are positioned in order to ensure accuracy in building. Second course commences again starting from the corner. Blocks are bonded together using block grip, an SABS approved thin bed mortar masonry block brick bonding system. Each course of KBB interlocking masonry blocks is positioned to create the KBB isometric exterior and interior walls. The fifth course consists of the first in a series of bound beams using the KBB lintel block, which is positioned every fifth course around the exterior and interior walls. This series of bound beams adds additional strength to the structure which conventional buildings do not have. The windows and door concrete block surrounds add an aesthetic structural element that allows for doors and windows to be fitted after construction is completed. Windows and sill blocks are reinforced using Y10 steel and 25 MPa concrete. Y10 steel is strategically positioned, following in which 25 MPa concrete is cast. The K-lintel block brick must be inspected by a qualified KBB Quality Control Site Inspector prior to continuing with Step 3 of the KBB superstructure construction phase. Step 3. The KBB wall system. Window profiles are continued to be positioned in order to ensure accuracy in construction of the window frames using the window sill block. Electrical and plumbing services go hand in hand with the construction of the KBB superstructure. No chasing in a KBB superstructure for installation of electrical or water services is allowed. It is critical to ensure that all window sills and bound beams, including the steel fixing, are inspected prior to casting of the 25 MPa concrete. Electrical and plumbing services continue to be installed in conjunction with the construction of the superstructure. At door height, the K-lintel block brick must be inspected by the KBB Quality Control Site Inspector. Step 4. Roof structure and anchor detail. Positioning of the roof anchors required for the fixing of the roof trusses are strategically spaced according to the roof trusses design layout. The bound beam is positioned and inspected by the KBB Site Inspector. Once again, the electrical service conduits continue in conjunction with the construction of the superstructure. Roof anchor brackets are once again strategically positioned in preparation for the casting of 25 MPa concrete. Y10 steel is fixed in place in preparation for the casting of the 25 MPa concrete bound beam. Cast-in roof anchor brackets are positioned in the bound beam in their correct positions during the casting of the concrete. Roof trusses are positioned in place on top of the bound beam. DPC is wrapped around each wooden truss before it is bolted to the roof anchor. The role of the DPC is for wood preservation and allows for expansion and contraction, which reduces wall cracks. Roof trusses need to be braced once in position in order to ensure that the positioning is correct when fastening the roof trusses to the roof anchor. No wall plate is required, hence beam filling is used. Note that at course 5, another K-lintel block is used which creates the bound beam as per the specifications of ensuring a bound beam is included every 5 courses as per the rational design specifications of the KBB system. Beam filling continues to follow the profile of the roof trusses. Final gutter block is positioned and cut accordingly to accommodate the overhang of the roof trusses. Double-sided radon shield underlay is applied, which reflects up to 97% of radiant heat. It further reduces the entry of external convective heat, thus providing excellent thermal insulation properties. Radon shield reduces pressure variances, decreasing the risk of roof tiles or roof sheeting lifting during windy conditions. Roof battens are used to secure the radon shield in place and for the fixing of the cement roof tiles. Commencement of external walls begins using Agreement approved skim plaster. Skim plaster is a cementitious plaster which can be applied at 3 mm thickness. The Skim plaster provides a smooth, durable, waterproof finish and is specified for problematic coastal regions for the prevention of water penetration. The fiber content ensures crack bridging and control. Skim plaster is also very effective in sealing all joints where blocks join. Cement roof tiles are fixed to the roof truss system. The color arrangement chosen provides an aesthetic roofing finish and brings creativity to the roof design. It is important to ensure that the KBB construction site is kept neat and clean at all times, especially as visits can be inspected from building control inspectors and even high-profile government dignitaries. Walls need to be clean and dry. Any loose materials need to be removed from the wall surface prior to commencing with paint work. ARP plaster primer paint is applied as a first coat. It is critical that the ARP plaster primer is properly cured before applying the first PVA finishing coat of paint. Walls need to be dry and clean. Moisture content has to be below a reading of 16 using a moisture meter during wet climatic conditions. The installation of ISO LAM 40mm ceiling panels. The ISO LAM panels consist of a fire-retardant EPS sheet laminated on one side of the panel with a PVC skin. The ceiling panels offer excellent thermal properties, and the thermal resistance R value of the 40mm panel is 1.1. Panels are cut to size using a standard cutting knife. Aluminium split H section strips are carefully positioned and marked for fixing under the roof trusses. Once the H sections have been fixed to the trusses and positioned in place, the split H section is divided and the adjoining section returned to the H section. This is conducted once the panel is positioned correctly. Roof battens need to be positioned in order to avoid truss movement. This prevents distortion of the ISO LAM panels during windy conditions when slight movement of the trusses may occur. The ISO LAM cornice is measured for cutting and fastened against the wall and the ceiling panel using silicone supplied with the cornice. The cornice needs to be carefully cut using a jig. Doors are hanged in their respective frames, making sure that clearances are correct and doors open and close properly. In laying the specified grade floor tiles, the floor area needs to be cleaned and free from any loose materials. A qualified joiner installs the specified kitchen cupboards as per the plan drawings. Radon shield underlay was applied below the cement roof tiles, which reduces heat reflection. ISO LAM ceiling panels were installed to increase the energy efficiency considerations of the building envelope. A solar geyser has been installed to reduce electricity consumption. On completion of construction and after clearing away all rubble and materials, the house is ready to be handed over to the new owners.